Okay, today we are going to be reviewing the new lab, IA221 Sensors Lab 6, which we're calling the Integration Lab. And I am going to be presenting this lab to you in the role of a project manager. And so as a project manager, my job is to make sure that you're clear in what you have to do. However, like most project managers, I am not perfect. In fact, like most project managers, I'm probably far from perfect. So your job is to listen to what I have to say and then ask questions until you personally achieve full understanding of what this system has to do. I am going to assume that you can read. You've read through my project documentation that I've already sent to you earlier. You've had a chance to look at it like a whole day. And so now you should be able to ask me really intelligent questions. However, I'm going to start off by just giving you my opinion about how important this project is and how easy it should be for you, which is very typical of project managers. So let's start off by sharing my little document here. And voila, here is my lab 6 project thought experiment. And here's the bottom line. I have got a new conveyor system planned. All right. I have already gotten the budget for it, and the budget is small. And like any good project manager, my job is to make sure that this system does exactly what it's specified to do within the budget. And the lower I can go on the budget, the more kudos I will get. And then I may or may not praise you as the actual technicians who do the real work. FYI, breaking the fourth wall for a second. Yeah, that's how project managers are. All right, back to my role. All right, so my system is going to be awesome. I'm going to use the cheapest possible PLC, which is going to be an obsolete PLC called a MicroLogic 1000 analog. And it's going to be 24 volts, just like all my other PLCs of this size in the plant. So I can use all my existing 24 volt power supplies that are floating around. And it has to be able to handle these small parts that come rolling down my 24-inch wide conveyor. These small parts look like this roughly. They're made of plastic, they're moderately heavy, and I have this great system in place that someone else is going to do that's going to knock these parts right off the conveyor when they are bad. They have the wrong color. So I want you, number one, to use a sensor that will tell the PLC a new part is coming down the conveyor. It has to be a nice, narrow, accurate, great sensor that won't accidentally miss the part. And also, it has to be consistent, reliable, and cheap. And it has to be able to go all the way across that 24-inch conveyor because I have no idea where that part might end up on that conveyor, one side or the other. And so then that information will tell the PLC that a new part's on that conveyor and tell me exactly when so the PLC can store that timing data. Then the next sensor needs to tell me whether or not this part has got the right color, because if it's not got the right kind of paint on it, it's not got the black paint, I want to kick that sucker right off into a bin. All right. So I need a good sensor that'll stare down and look at that part when it reaches that sensor. Now, I know, you're like, whoa, Rob, that part can end anywhere on that conveyor. How do I know I can mount that sensor right over where that part will see it? Well, I tell you what, we're just going to use a little imagination. Imagine that my other engineers are going to figure out a way to funnel that part down to a specific spot on the conveyor at that stage in the operation. So we're just going to assume that, okay? All right. So then the part's going to reach a bumper. It's going to stop at the end of a long line of parts, and it's going to hit this end of the line. And then I want to be able to pick up that part with a robot. So I have to know when that part's reached that bumper. The bumper is going to be made of ultra high molecular weight plastic, UHMW, and it's going to be sturdy. And I can mount that sensor somehow right into that bumper. It's got to be flush so the part doesn't bump around. And then my robot, you don't have to worry about this. My robot guys will work about that. My robot will go down, grab that little part, pick it up, put it onto go ahead and pick it and put it onto a pallet. But here's the thing. If that robot misses that part, like what if that part fell over? What if the little thing just went boop, fell over somehow? My little conveyorized funneling system didn't funnel it quite right and it popped right over sideways. Then I want to have a sensor built into my robot gripper that lets me know that that gripper closed all the way. If it closed all the way, I know I missed the part. Don't have to worry about the timing. The PLC will handle that timing. All I need to know is I have a sensor in there that'll go turn on when that gripper's closed all the way, because it shouldn't be closed all the way if it's grabbing a part. It should be open a little because it's got the little part in its little gripper. All right. And then, look, we've got to have some safety systems. We don't want to kill anybody with this here robot. So the safety systems, we're going to have a high fence. I think 6-foot fence would be good enough. No one can climb a 6-foot fence. That's just too hard. So we're going to have a 6-foot fence with a gate in it. And I want somehow the cheapest way possible that's still impossible to defeat by my operators, a way of having a sensor tell me when that gate's open so I can shut everything down. And then on the fourth side of that fence, it's open because I got a pallet truck that goes in there. I need to know when somebody walks through there or when the pallet truck goes in there and shut the robot down or pause the robot if something does enter in there. Right? So I need some way to stretch across 12-foot length, 10-foot wide fence opening. And last but not least, I'm going to have fork truck in there, and I want that driver of the fork truck, no matter what an idiot he is, he can't even see what he's doing. He is going to know when he gets closer and closer and closer, and he's parked right in front of that pallet. And we're going to use a 3-color column there. That means you need to give that PLC an analog signal and let that PLC know based on the analog signal how far away that fork truck is from the pallet. And then the PLC will do its work to figure out what light to light. You don't have to worry about that. And as a bonus, I'm thinking about using a vision system that'll stare down at that pallet and let me know when that pallet is full and all the parts are in the right places in the right spots. And it'll give me a signal if that pallet is not correctly filled. All right, that's the end of my little presentation. I'm going to turn off my recording here.